All right, I'm going to redo this chapter 3 question 35 video. I'm going to try to make it in one take. I'm kind of tired. It's been a long day. So stick with me here. The first video I sent you, I don't still believe it's wrong. It's just going to be different. It depends on what the book is asking. So, but one of the students, Tien Hua, I'm probably killing that name, but they put me to the right direction. I've been researching it, and I think either the video I sent you yesterday, I would still consider correct. It's logically correct, but even though the numbers are a little bit different, but I'm going to do it the way I think the book wants you to do it. So, first of all, they want you to make a joint probability distribution for marital status and educational status. Okay, so we're going to switch over to the Excel spreadsheet. And you'll see that I have all the raw data here. I deleted everything else. I just kept the school column heads and the marriage status row heads. So the first thing we're going to do is make a joint probability table from this data down here. So this first square here, right? Whether they did not get a high school graduate or they were never married, that's simply going to go up to the function bar. We're going to hit equal. We're going to take that intersection right there, right? That 4 million people didn't graduate high school. They were never married because they're losers. Just kidding. But we're going to divide that by the grand sum, right? So again, I'll say that again. So 4 million people out of 177 million people were never married and they never went to high school. Enter. Boom. So that's the percentage, about 2.3%. So I'm going to go up here, work my magic. I'm going to put my $sign, lock in the H, before and after, hit enter. That's going to allow me to drag the formula, but it keeps the divisor the same, right? So the divisor for all of these different cells is going to stick at 176,829,455. I'm going to drag it down, and that is my new table. Okay, so the one I had before, a little bit different, but I will accept either one of those. So that's the first part of this. Let's go down to the individual questions over here. A probability that the person is divorced and has a bachelor degree, okay? Divorced and a bachelor's degree. That is, again, that's just a joint probability. So we're going to go into our function bar. We're going to hit equals. Let's see, divorced. There's the column. There's the row for divorced. And a bachelor's degree. So bachelor's degree divorced. So there's the number. And again, we're simply going to divide that by the grand mean. And there's our answer, okay? And that's the one they have in the book, so I'm pretty sure that's the way they want you to do it. So these other ones, they're conditional probability. So give me a second while I get set up here. All right, here's question B. This is where I have to apologize. I probably screwed up, but it's a wording issue. The way the problem is worded is different than what I'm used to, okay? So what's the probability that someone known to have an advanced degree is married with spouse president? So we got to break down that sentence, right? Conditional probability, that means that one event is based on the other event. So the way I was always taught was on condition that B is in existence, then what is the probability that A will happen? I'll say that again. When B is in the condition, when whatever the event is, B is already activated or happening, then what is the probability of A? It can get kind of spicy here. So this is the formula, right? This is the way I was taught, was the probability of A given B. So mathematically speaking, it's the probability of A and B, that's when you just multiply them together, divided by the probability of just getting B. So with our problem, we have to decide which event is the probability of B. That's the thing that has to be in place before you can calculate the A. So in other words, which is the condition that must be met first? And this is what we used to call given. So the given first has to have an advanced degree. Okay? So that would make it your probability of B. But we used to call it on condition that probability B, in other words, on condition that the advanced degree is in place first, then the other one becomes automatically probability of A. So this is how you write this up. The probability of married with spouse given that they have an advanced degree, or probability that they're married with a spouse on condition that they have an advanced degree. And then the rest of it is just mathematical. So let me go ahead and punch this out. All right, I'm already confused here. So the probability of married and advanced degree divided by probability of advanced degree. Let's get this going. So probability of married and advanced degree. Okay, so let's click this. So I want the probability of married and advanced degree. So equal sign, parentheses, probability of married with advanced degree. So married with spouse present. And advanced degree is this number, kabam. We're going to divide that by the entire grand sum again. So there's that percentage right there. So the probability that they have an advanced degree and they're married with the spouse present, that's A and B. We're going to divide that by the probability of B, and that is that they have an advanced degree. And so let's put another parentheses up there. The fact that they have an advanced degree is this number divided by that number again, close parentheses, and that should give us that one. Boom, 6891. And that's what the same answer in the book. But I got to be honest with you real quick. So what this is saying is, if they have an advanced degree, and that is given, they have to have an advanced degree first, and the probability that they're married with a spouse present is, I don't think this is right, because this is about 70%. So this is saying 70% of the probability is that they have an advanced degree and they're married with a spouse present. And that's not the case. That is so far off. So I'm not agreeing with it, even though that's the answer in the book. But let's do this last one. So this last one is, I already forgot, hold on. So here's the last one. What's the probability that given an individual is known to have never been married, and then the other is the least an associate's degree. So event B is that they've never been married, and event A is they've either had that they've never had an associate's degree. So again, I'll just put that out on condition that they've never been married. That's the B. That's the event B we're looking for, and that they at least have an associate's degree is the A. But at least it has an associate's degree. Then we have to do it for the bachelor's degree, and then we have to do it for the advanced degree. And let's go do it. And I'm going to do it real fast. So I'm going to pick that cell right here. I'm going to go up here. Give me a second. I'm going to go ahead and type in the code. So let me explain the code to you. The first number, up to this plus sign, is E3. So that's the probability that they are never been married and got an associate's degree, divided by the grand sum. That in turn is divided by H3, which is 1, 2, 3, the total amount that they've never been married, right? And that is divided by the total sum. That's the first term. The second term, after the first plus sign, F3 is the bachelor's degree, never been married, divided by the total sum. That in turn is divided by never been married. It's the same thing, divided by the grand sum. Okay, the last term, G3, is the probability that they got an advanced degree, they've never been married. That's divided by the grand sum. And then that in turn is divided by the same thing, that they've never been married, 25 million divided by 177 million. And that's it. Let's hit enter. And that is your answer. And again, I apologize, but that's it for now. I have to go teach another class. MGZ out.